So that's the input for solver. Here's the answer report. Let's look at our graph. Where we go? Graph, here it is.
Do you have to name yourselves to get anything that's named?
No. No, you named it in solver. So inside here we found that based on our total enumeration method that the optimal solution would be 2060, 180. And what this is saying to you right here is 2060, 180. Right there, that column of information matches this row right here. 2060, 180. Notice that the original value, when my guess was 1 and 1 and 5, it tells me that was my original guess. And it is telling me I do not have integer values here. I didn't force the GeoPedal problem to give me an integer. We just got lucky. It could have been any number. But the optimal solution turned out to be whole numbers, okay? One other quick thing. This picture is telling me another piece of information about this linear program. And what it's telling me is, of all the constraints, C1 and C2, which is the carpentry and finishing, are the two constraints that establish the extreme point. That is the optimal solution. How does the computer, remember eventually we can't draw the solutions, we're going to be totally dependent upon the output of the solution from the computer. How does the computer tell me that? It tells me that right here. It says that C1 and C2 are binding constraints, and they have no slack, meaning I'm using up all 100 hours and all 80 hours. But the demand constraint is not binding, and it has 20 soldiers left, because its constraint said it had to be less than or equal to 40, but in the optimal solution it's only 20. So let's play a game. Right here with Jack. Right here is the origin. Going right straight through here to Martha. Right straight to Martha is the x1 axis. Okay? Right into the board is the x2 axis laying on the floor. Right? Everybody playing the game. I'm now going to adjust my arms to the -3/2 slope. I'm on the 0, 0. I'm maximizing. So I'm going to move as far away from 0, 0 as I can get until I get out here to what? 20, 60, 180 is the ISO profit line value right here. I cannot move farther away. It's like my legs are bound. Right? I can't go any farther. So the two constraints that are binding me right here are C1 and C2, which the words are the carpentry and finishing. Okay? But at 20 and 60, if I kept going here toward Martha, out not 20, but all the way out here to 40, there's another constraint right here. See? 40, 40, 0. I'm 20 soldiers away. So there's 20 soldiers of slack in that constraint. Up here is the binding constraint. So in theory, I can look at this table and see that picture. Just like that little kid could see dead people. In that movie, right?
Is slack 40 minus 20 or 20 minus 0?
40 minus 20. 40 minus 20. Because I could, in theory, and the optimal solution is to make 20 soldiers. That constraint would allow me to make 40, so it's the slack in the constraint.
Is there any analysis you can use with that slack?
It's called sensitivity. We're getting to it. Okay? 0, 0. X1 axis, X2 axis. Cock my arms at -3/2. Walk as far away as I can get. And then I am bound. At 20, 60, 180 is the value of the ISO profit line. I cannot get any farther away and still be feasible. I'm still touching that feasible region at that one point. And I have slack toward that one slope. So this little table, a geeky guy like me, I see that picture. Because I've been doing this 25